Greetings. This is an advanced tutorial on using RGB curves node in 3D space. Alright, this subject is extremely complicated. I could not find any tutorials on this. I could not find any information on this whatsoever. So, I've been playing around with it, and I'm going to try to teach you what I've learned. Alright, so I've started the cube. Let's go Geometry Nodes, new node, kill the original. Alright, I'm going to start with a circle and a line. And curve to mesh. It always hides for me. Curve to mesh, yes. And that should generate a cylinder. Alright. Let's make it 10 meters tall. And let's resample the curve count of 11. Because there's 11 points in something that's 10 meters long because there's a 0 point. Alright, so here's where it gets incredibly complex. RGB curves. Alright. First, it goes up in the z-axis, and I want to alter it in the x and y direction. So, set points, or excuse me, set position. And I want to go in the normal direction, so I'll do normal, vector math, multiply, times this, and that goes into there. Alright, I do want to do another multiply, or do I? Alright, let's Alright, I want to do position, separate, and I want the Z component to go into color. Here is the most critical part that took me about 8 hours to figure out because there's no documentation. The number coming into here has to be between 0 and 1. I did not know this. I had no way of finding out this, but that's the most critical part. So, since we know that this is 10, what we're going to do is we're going to set it as a specific number, and we're going to set the Z component. Let's see, press N, click on group, rename this to height. Now that height's going to be used all over the place. Add 1, plug that into there. Why did that go away? Oh, there we go. So now it's got a height of 10. And it's resampled for 11 points. And this will be divided by the height. That goes into the factor. Right now all the curves go from 0 to 1. Alright, the C, I believe, is like a uniform in like all directions. The Z will always be 0 because it's going along the Z, so there's no curve for Z. I mean, it doesn't have any effect, I should say. There is a curve, it just does nothing. But here's where it gets interesting. You have an X curve. Let's reset this. The X curve and the y curve are separate. So you can get very interesting shapes that are different in the x and y direction. If you want non-uniformities, the r is x, the g is y, and the b is z. C is like a universal effect. It hits all three of them. Which, you know, that can be useful as well. And you can do other things like throw in multipliers here. You could clamp it, do a map range. If you do a map range, I think you have to do, you can't do a map range on a vector, or can you? Oh, you can. Well then. You know, you can map it out in different directions to get different multipliers. See what else is there. Oh, yeah, make sure you multiply by the normal. Ah, here's another big one. Let's say you want to do it twice. You would need to make sure you use the normal of the original mesh. Because if you use this one, there are instances where the normal will no longer, it will have been changed by this one, which can result in some really nasty artifacts. And another thing is, let's say you have an object where each quadrant is different. Like say, the back right is not going to look the same as the back left. And the front, like all four quadrants, will be a different shape. What you can do is on this one, no, not set position, I just need position, where, let's see, x, no, greater than 0. See, that'd be an x greater than 0, so it'd be that whole half there. But if you want the quadrant, you'll have to combine that with y is greater than. So that would give you just this one quadrant. That'd give you just that one quadrant is being changed. Now here's where the normal maps get all jacked up, because these faces along this edge will have a normal straight towards you instead of out the direction it should be. So you'll have to do a transfer attribute, and then do the normal as the attribute, index, and vector. So you'll want the normal as the attribute. The index is the index of the point. So you just leave that alone. That automatically changes on a per point basis. So this here would multiply, instead of the normal here, use the original normal. I mean, technically you could plug this in both places and be the exact same thing. But if you plugged in this to here for the second half, you'd get some really screwy things. Alright, so let's duplicate this. But instead of greater than, we'll use less than or equal to, plug into here, and plug this into here. No, offset. Plug it into offset, and copy all this, Control Shift D to duplicate to keep the everything connected, and let's reset this curve, Now you've got a completely different curve in the front than you do in the back. And there will be a smooth transition between the two. Well, there'll be a smooth transition if you keep for like this quadrant, you need to keep the x the same and only change the y. So I actually need to delete this and reduplicate it. I want to keep the smooth transition. The x one has to stay the same. Like if you reset it, you'll get not quite a smooth transition, especially if it's very large numbers here. So Control Z to undo that, but I can change the Y one. See, now I get the shape in the back and a different shape in the front. Now if I do the front, I have to make sure the Y is the same between the two of them, but then I can change the X. And the last quadrant has to be the same in the X as it is on the Y. Now you might be thinking, why would I do this? Well, you can get some really interesting shapes that you just can't get any way other than modeling. For example, alright, let's mute this one and mute this one. What does that look like to you? And this is done using quadrant-based RPG curves. And this right here is how I got the X from one of the other quadrants, and the Y must be this one. Yeah, see, it's slightly different. Got the Y from this quadrant and the X from this quadrant. So these two I did not edit because I had to have them from the other two quadrants to get everything to line up smoothly. Now, before I tried like separating the meshes out and just using this for the input for each one. If you do that, you'll end up with very square edges. It'll basically be a square with curves instead of a sphere with curves, or circle with curves. My own personal goal is to be able to create an entire 3D model, 3D model of a human using nothing but geometry nodes. And that task is much harder than it sounds. Even once I got the leg, I've got a foot, but attaching the foot to the leg gets artifacts. And I have not yet figured out a way beyond this point of how to not have artifacts. And I really hate using booleans because they're a lot slower. This one's not that bad. It's only 47 milliseconds. I've seen a lot where they're like 800, 900 milliseconds. And when you have a bunch of these that are 800 milliseconds each, 10, 20, 30 seconds each time you make a single change to the model can get useless. And yeah, this is the foot without any toes on it. Oh, this right here is another thing created by RGB curves. All right, let me see if I can show just the foot. All right. The arch. So the arch is in 3D space. That was incredibly difficult to do. Or at least for me. You know, I'm not an expert in Blender. All right, top, top, bottom, bottom. I think it's this one. All right. To create the arch, I had to multiply a curve in the x direction with, actually no, both of them are excuse me. Both of these are in the z direction, but their factor, one uses the x, one uses the y, and both of them have to be normalized to be from 0 to 1. So I had to use the x as the input, so the further the curve for this one is in this direction. The further away from the 0 that it gets, the higher it gets up here. So that's what you want, but if you do that for all of them, it basically makes a ridge all the way, like the entire, this side of the foot, right side of the foot, is up at once, and you don't get an arch. Because this is a three-dimensional space of an arch. It's basically the top of a sphere, or a semicircle. And I combine that with an arch in the y direction. So the further away from 0 it gets, or well, basically the middle of the foot, gets this. But if you do just this one, there we go. You get this. It goes all the way across. It's not what you want. If you do just this one, you know, this side of the foot gets pushed way up. So you multiply and you get an arch. You also can get some really interesting effects if you want the other way around. Like multiply one of them by -1. And you can get different effects. I multiply them both by -1, otherwise it comes down instead of going up. Like this goes up, but in the downward direction. And I was just making hand gestures as if you can see what I'm doing. Alright, so that gives you a three-dimensional curve by using the y for one, the x in the other, and you multiply out. Now this is the z curve for both of them. So that gives you two-dimensional curves and three-dimensional curves. And I do believe that is everything that I wanted to cover. Alright, I think that's everything. I hope you enjoyed it and learned something.